All right, so now we're moving on to our next video, and that's going to be solving one-step inequalities. All right, we're going to first refresh our memories on solving one-step equations because you're going to see it is the exact same thing when we're solving inequalities as we are when we're solving equations. So our learning objective today is one, knowing how to solve our inequalities, and then we're also going to practice graphing our one-step inequalities. And soon we're going to branch off into multi-step inequalities and equations. All right, so let's go ahead and get started on this video. All right, so just to first, before we start solving any equations or inequalities, let's just go over the inverse operations again. And remember, our inverse operations, we're looking to undo what is being done to our variable. So if there is addition being done to it, we will then go ahead and do subtraction. If there's subtraction being done to it, then we will do addition because, as we talked about before, well, 5 minus 5 is equal to 0. So they're going to cancel each other out. So we're going to just be left with just our variable. If there's multiplication, then we will go ahead and do division. And if there's division, we will go ahead and do multiplication because they'll cancel each other out as well because 5 divided by 5 is going to be equal to 1. So if you multiply and divide by the same number, it reduces itself to 1, which is then going to leave us with just our variable. All right, we're going to go through really quick 4 examples with our equations and then move on to our inequalities. All right, so just to refresh our memories with this, first we look and see what is being done to our variable. Well, it's x plus 4, so remember, it's addition, so the inverse of addition is subtraction, so that means I will subtract both sides by 4. And 4 minus 4 we know is 0, so it's going to isolate our x, and 9 minus 4 is equal to 5. And remember, it is really important that you're doing this to both sides of your equation. We went through in a separate video why we need to do that. So if you're still struggling with that, please just send me an email and we can go through this. But it's very important that you don't just know, okay, addition, subtraction, but it's that we need to do it to both sides of our equation to keep it balanced. When we see a subtraction, so x minus 8, that's subtraction. When we see subtraction to our variable, we need to add the whatever is being subtracted to undo it and eliminate that and isolate our variable. So we will add 8, and what we do to one side, we have to do to the other. So x minus 8 plus 8, they will cancel each other out, and we're left with just x is equal to 12 plus 8 is 20. So here we see it's 3 times x is equal to 18. So whenever we have multiplication, we will divide each side or divide by whatever is being multiplied to isolate our variable. What we do to one side, we have to do to the other. 3 divided by 3 is 1. So it becomes 1x, which we don't have to write because we can just write x. And 18 divided by 3 is equal to 6. All right, and then the last one, we see this as x divided by 5 is equal to 10. So whenever we have division, our inverse operation is multiplication. So then we will multiply both sides by this 5. We see that 5 divided by 5 is 1. 1x we know that we can just write as x. So we can just say x is equal to 10 times 5 or 50. All right, it is really important that you do not forget to do it to both sides of your equation. Otherwise, you are not balancing out our equation and you won't be solving it correctly. All right, so it's really important that you guys understand this because you'll see it's the exact same thing that we're going to do in our inequalities. All right, so we look. Our problem is x minus 4 is less than 8. Just like we do with an equation, we identify what is being done to our variable. Well, we're subtracting. So the inverse of subtraction we know is going to be addition. So just like with equations, we're going to add that 4 to get rid of it. So in order for us to solve, we need to isolate that variable. So then we will go ahead and we will add 4 to get rid of that 4. And what we do to one side, we have to do to the other, just like with our equations. We know that 4 minus 4 or negative 4 plus 4 is 0, so it just gives me x plus 0 or x. Our inequality does not change, and 8 plus 4 is equal to 12. So now we have x is less than 12. Once you isolate your variable, now we can graph. We can't graph until we isolate our variable. So the first thing that we're going to do is we're going to look at our inequality. We're going to say, what type of point is this? Is this going to be a closed circle or is this going to be an open circle? And remember, less than or equal to or greater than or equal to, if it's equal to, then it's a closed circle. If it's just less than or greater than, it is an open circle because we cannot include it as our solution. So then we will go ahead and draw an open circle. Remember, I'm going to start doing mine above the number line just to make them neater. So then we have an open circle at 12. And when we have this, it separates this into 2 separate regions. So we have 13, 14, we have 11, 10, 9. So we're going to pick two numbers. All right, I'm going to, let's use a different color just so that way you can differentiate. Let's use purple. All right, I'm going to pick two numbers. I'm going to pick 10 just because 10 is easy to work with. And I'm going to pick 14 just because it's the one I felt like doing. All right, now we have two regions. We have the region to the right and a region to the left. We're going to plug these back in. Now, it's important that you plug it back into the original problem, because if you made a mistake somewhere along the way, you might not realize that you did if you're not plugging it back into the original. So then we would have x minus 4 is less than 8. That was our original problem. So I'm going to pick 10. Well, 10 minus 4, is this less than 8? Well, what is 10 minus 4? 6. Is 6 less than 8? Yeah, of course it is. So we know that this side works. Now, let's just test the other side as well just to see if this one does or doesn't. So it's x minus 4. Well, 14 minus 4, is this less than 8? Well, 14 minus 4 is 10, and 10 is not less than 8. It is greater than 8, so we know that this side is not a solution. So then since my solution was on the left-hand side, and I know if one of them satisfies it, they're all going to. That's the good thing about testing these, is that it's allowing us to just test one point for the entire region. So then I will draw this line going to the left. Remember, you must put your arrow. A lot of you guys were forgetting that in the question you guys were doing for me on the pair deck. You must put the arrow because it means every number beyond that as well. All right, and now this is our solution. And remember, one of the things I told you, if our variable is on the left-hand side, which is it? Yes. Then that means we can also use our inequality to tell us which side our answer is going to be. You see it's pointing to the left. That means our answer is going to be to the left. All right, you should still get in the habit, though, of testing your points, because you don't want to either make a mistake, and I'm going to write one purposely on here of what we would have to do first, but you don't want to just get in the habit of reading that. You want to identify, because when you guys get into higher level maths, especially like calculus, you'll see you actually do this where you test these regions and see, is it work, is it true, is it false? And it helps us to graph our equation, or to graph our problem, and then also to understand our problem. So knowing this habit of testing a region and seeing if it holds true is something that you will do throughout the rest of your math time in school. So it's really important you guys understand what we're doing with this. If one point in this region works, then that means all of those points in that region are going to work as well. That's why we only have to test one and not all of them. All right, let's go ahead and get into our next problem. All right, now, first thing we do is we look at our problem. 3 times x is greater than or equal to 21. Well, what is our inverse operation of multiplication? Division. So I know I'm going to divide. So I'm going to go ahead and I'm going to divide each side by this 3 just so I can isolate my variable and I can start graphing. Well, 3 divided by 3 I know is 1. So x is going to be greater than or equal to 7. So now I've isolated my variable, and now I can go ahead and graph. First thing, though, is we look at our inequality. Is this going to be a closed circle or an open circle? And whenever we have equal to, we know it's closed. So I'm going to go ahead and close my circle at this 7. All right, now I know that this is going to separate my region, my graph, into 2 separate regions. I'm going to go ahead and test 2 points. Let's go ahead and test, let's do 10 because 10 is easy to work with. And let's do 4 just because that's the one I feel like doing. Let me pick a different color, though. Let's do this. All right, 4. So remember, when you're doing these, you're going to substitute them back into the original problem. You do not necessarily have to do that right now. But in the future, when you guys get into really harder maths, it's really important that you guys are doing that. All right, so let's go ahead and plug this into our first one. So we're going to substitute in 4. So 3 times 4, is this greater than or equal to 21? Well, 3 times 4 is 12. Is 12 greater than or equal to 21? You should know that and know that is not. So this region is not a solution. All right, then we'll go ahead and we'll test in the other one. So 3 times 10, is this greater than or equal to 21? Well, 3 times 10 is 30, and is 30 greater than or equal to 21? Yes. So we know that this side is our solution. So since the right side was my solution, because that's where 10 was, I know that my graph is going to go in that direction. I must put the arrow at the end, and there is my graph. All right, and remember, just like I said in the beginning, we can just read that inequality if the variable is on the left-hand side, which it is, and the inequality is pointing to the right. Therefore, my answer is going to point to the right as well. All right, we're going to do one more problem, and then that'll be it for this. All right, so if you look here, you do see that our variable is on the right-hand side. So what I would actually suggest that you do is I would suggest that you rewrite this and put your variable back on your left-hand side, especially if you're going to just read your inequalities. So that means I'm going to write x minus 2 here. And to rewrite it, actually, let me just change this color. Let's do blue. All right, so I'm going to rewrite it. So we have x minus 2. So to rewrite it, I look at the inequality. Is it opening towards my variable or closing towards it? Well, it's closing. So that means I'm going to write my inequality still closing towards my variable, and then we're going to have 1. So we'd read this, x minus 2 is less than or equal to 1. First thing we do is say, what is being done to our variable? Well, subtraction. And subtraction has an inverse operation of addition. So I will go ahead and add 2 to both sides. We know that this is going to cancel out, and now we get that x is less than or equal to 3. Once again, is this a closed or an open circle? Well, we know it's going to be closed because it is equal to, so we will choose our closed circle. I will plot that at the point of 3, and now I'm going to go ahead and separate my graph into my multiple regions. I'm going to pick 2 numbers. So the first number I'm going to pick is 5, just because it's the one I just feel like dealing with. And then the other one I'm going to pick is going to be 0, because 0 is really easy to work with. Right? And now, remember, we plugged them back into our original problem. Now, since I rewrote it, I'm going to plug it back into this one. X minus 2 is less than or equal to 1. Well, when we plug this in here, we would have 0 minus 2 is less than or equal to 1. Well, 0 minus 2, we should all know this, is negative 2. And is negative 2 less than 1? Yes, it is. So now we know that this region works. And now I'm going to go ahead and do the other region just to make sure that that one doesn't also work, because if they both work, I should maybe check my work or see if there's a mistake I made anywhere. Right? So then we would have 5 minus 2 is less than or equal to 1. Is that? 5 minus 2 is 3, and 3 is not less than or equal to 1. Now, you will start to solve inequalities in the future that both regions actually can work, but we're not going to do that while we're learning it, because we're just learning the basics right now. All right? Since it worked on the left-hand side, I know that all these numbers are going to work, so that means my graph is going to go to the left-hand side. All right? Now, if you were to use our inequalities, you see here when our x variable is on the right-hand side and we don't move it, you might mistakenly say, well, this is telling me I need to go to the right. Well, we know that that's not true, right? Because our graph actually, after testing it, went to the left. So it's really important that if you are going to read your inequality to help you with your graphing, which you will naturally start to do that as you get older and more comfortable with this, but if you read this, your variable must be on your left-hand side like I rewrote it here. All right. There are some other rules to your inequalities, like what happens when you multiply or divide by a negative number, but we're not going to cover those because that's something that you'll learn in 7th and 8th grade. We're just doing the basics of it right now. All right. So that is it for this video.